Hello, in this video, we're going to learn how to calculate mean and standard deviation from a simple data set. So you guys probably remember that in your class, I asked you what's the average amount you spend on gas every month, and you answered uh, like four of you answered. So first person answered $120, second person 400, third person 300, and the fourth person 100. And these are values of data. So these are the excess, small excess, small cap excess, and the name of the variable is gas cost. Remember, this is the big X. That means the capital X, which is the variable name, and these are the small x. And if we want to calculate the average from this, that means uh, the expected value of these numbers, that means every month how much should I expect to spend as a new student, then I can get the average using Excel. So first, let's calculate the sum, and the summation sign is this sigma xi. By xi, I meant from 1 to 4, x1 plus x2 plus x3 plus x4. So what's that? That's the sum of these four numbers. Okay. And how many students are there? So n is my sample observation. So number of students are 4 here. So n is count. How many data points are there? There are 4 data points. Now I'm gonna get the average if I divide this number by this number. So 920 divided by 4. This is my average. In other way, Excel can give you the average if you just type in average and then parentheses open and close and then select the numbers. Is the same. So this is in a way giving us this both are this summation xi over n is my average. Okay. um, so what we can do, we can calculate the deviation about the mean. Why is that important? Because if a new student comes and then we tell them that okay, you can expect to spend $230 per month on gas, that number might be too high for some students, because we can see here that two of the students don't even reach that number. So we also need to understand that there is a variation in the data, and that new student should learn that as well. uh, with the mean, it's also important to understand how scattered the values are around the mean. So for that, let's calculate the deviation about the mean. Deviation about the mean. And that, so this is xi, and the deviation about the mean is um, xi minus x bar. And what is the x bar? X bar is the sample mean. So this deviation about the mean. And by this, I actually meant this is the x bar. X bar. So they're the same thing. X bar is the sample mean. So this is 230. And we're going to subtract 230 from each of these numbers. So I'm going to type this. I'm gonna fix 9 so that I can just drag this rectangle down below to get 230, this number copied here. And this is my sample average. So I'm gonna write x bar here. That's my sample average. Okay. So sample mean And this column shows the deviation about the mean. So every single observation minus the mean. And notice this first student spends $110 less than the average. The second student spends $170 more than the average. So there are variations in data. Now, if we want to calculate the average of these numbers, then what we get is zero. Why? Because the mean is measured as the measure of central tendency. You can see the data variation, but the mean, the average, the expected value, the center of all these variations is 230. And if you subtract 230 from every single number here and then add them together, then the expected deviation will obviously be zero because expectation is the mean and expected deviation is zero because from the mean, every corner, whatever variation you have, if you subtract mean from that variation, then on an average, that will be zero. Okay, now since this is zero, so we don't get any standard measure for the deviations. So let's try a different way. Let's get rid of these negative numbers by first taking the square roots of the deviations about the mean. So I'm gonna write it here, square roots, um, this to the power 2. Okay, so first I'm gonna, I did what? I got rid of these negative numbers. Now everything is positive. And now what I'm gonna do is to add them together or use the Excel command sum. This is the sum of the square deviation, sum of the square deviation. So I'm gonna write it here. This is what the sum of square deviation. Okay. Now, if I divide this number by 4, then ideally I should get the average of these squared deviations, right? So if I divide this number by 4, then I'm gonna get the average of this number. So the average deviation of average square deviation is this, and this is how we calculate variance in population, but not in the sample. I'm going to talk about that in a minute. Um, and if we take the square root, if we take the square root of this number, SQRT, then we are going to get the deviation, standard deviation, and that is in dollars. Why? Because our original unit, the gas cost, was in dollars. So this standard deviation is also in dollars. That is $125.3. So the new student can expect that, okay, the average is 230, but it can vary by $125 per month. Like it can go 125 below or 125 above the this number above the mean. Now, one thing that I should mention that the formula that you use here, if I divide it by n, this number by n only, that's the count 4, then what I'm going to get is population variance or population standard deviation. Instead, if we want to calculate the sample variance or sample standard deviation, then I need to subtract 1 from the count. So This is my sample standard deviation. I have subtracted 1 from the count, the number of observations in the data. Why? Let me show you. Let me show you a thing in the slide. So for sample standard deviation, we have this formula where you divide by the number of observation minus 1. But in the population, for the population standard deviation, you divide just by the population of number of observations in the population. Why is that? Because in the sample, you are using x bar, or the mean. That is, you are not free to choose the mean when you are collecting the sample. If you choose the mean, then you must let go one observation. You are not free to choose one observation. In the population, you know all the values. You know there is only one true value for mean. There is only one value for each of these observations. So there is no process of selecting. But whenever you try to select in the sample, that means if you select three of this, let's say if you have three observations in the sample and you randomly pick two of them, then to leave the mean as it is, you cannot choose the third number freely. So the third number has to be dependent on the mean. On the other hand, if you can pick the three numbers, then you cannot choose mean as you want, as you wish, because mean of those three numbers will be determined by those three numbers, by the third number specifically. So you lose 1 degree of freedom to use the mean. And that's why for the sample standard deviation, you use n minus 1 instead of n. Okay, now that we got that cleared, um, I'm gonna show you this picture where, remember, I see that the new student can expect the gas cost can be 144 above or below. Then how much does that variation cover of the actual data set? I'm gonna go back to this picture here. So if you add and subtract one standard deviation from the mean, usually that covers 68% of the data set, of the data variation. So 34, 34, if the data is bell-shaped or normally distributed. If you multiply the standard deviation by 2 and add and subtract from the mean, then usually that range, these two numbers, are going to cover 95% of data variation. And if you multiply the standard deviation by 3 and add and subtract with the mean and from the mean, then that those two numbers usually cover 99.7% of the data variation. So that means if we, uh, let's say, add and subtract, let's say, um, add this standard deviation, sorry, let's add the mean plus minus the standard deviation to get the lower range, and then mean plus the standard deviation to get the upper range. These two numbers should calculate 68% of the data variation. And we can see how. So from 85, all these numbers, most of these numbers are falling between these two numbers. And if we multiply standard deviation by 2, if we multiply standard deviation by 2 and then subtract and add, subtract from the mean and add to the mean, we're going to get two more numbers. That's going to cover almost the full set of these numbers. So that's how, if the data set is has more variation, then you are going to see uh, if you have more data points, then you are going to see these values are more like to be true. And since we have only four data set, usually if you have like less variation in the data set, then mean plus 2 standard deviation will cover the entire thing, entire variation. Hope this clarifies. I'm gonna talk about how to calculate the frequencies and how to calculate the standard deviation from frequencies in the next video. Thank you.